Hello everyone, I'm Sahiti and I'm going to present Eclipse OpenG9 and Eclipse OMR AX64 just-in-time compiler implementation, baseline, and optimization on behalf of my team with CAS Atlantic at the University of New Brunswick. Eclipse OMR is an open source language runtime builder that supports many different hardware and operating system platforms. One of the targeted domains of OMR is the embedded computing market, where computing resources like the CPU, memory, data storage, etc. are constrained. Researchers have chosen the 64-bit ARM platform, AX64, a platform that is widely used in smartphones, microcontrollers, and IoT devices. The open design of ARM chips allows many manufacturers to make systems on chips which lower the cost for the end user. It also allows rapid scaling in server infrastructure and low power consumption at the same time. An initial minimal viable product version of OMR for the AX64 platform has been completed and is available in OpenJDK plus OpenJ9 early access releases on adoptopenjdk.net. Talking about TRJIT baseline, we will benchmark our evaluation of the interpreter and TRJIT on AX64 against OpenJ9 on x86-64. We'll also pit the AX64 JIT against itself among different caliber of AX64 devices. This benchmarking will provide a baseline for comparison of other future AX64 JIT features and optimized components. Speaking of optimized inline array copies, the optimizer in the OpenJ9 compiler will recognize a call to system.arrayCopy and then turn it into an array copy intermediate language opcode, either primitive or reference. The Java class library is a collection of loadable libraries used by Java programs during runtime. The arrayCopy method is a static native method of system class of JCL, which is to copy an array of elements from a source array to a destination array, which requires at least 3 arguments. The arrayCopy method has 2 versions, which are primitive arrayCopy and reference arrayCopy. The children of these 2 versions give the input details for the arrayCopy implementation. For both versions, a source byte address, destination byte address, and the length in bytes are in common. In the 5-child version, 2 additional children, source and destination array objects are included. A specific arrayCopy implementation is available based on the element type such as int8, int16, int32, float, double, and address. In Power Compiler code, different implementations for vector support extension for recent Power versions and floating point units are available. In AX64, arrayCopy implementation will include a combination of optimizations from other architectures while taking advantage of exclusive AX64 architecture features such as load store pair. The performance is expected to improve after implementing arrayCopy. Coming to SIMD vector support, the concept of single instruction multiple data, SIMD instructions primarily evolved to accelerate the performance of multimedia applications. It bears more significance to applications involving motion video, real-time physics, and graphics, where repetitive operations are involved on large arrays of numbers. SIMD operations refer to a computing method that enables processing of multiple data with a single instruction. Vectorization is often referred as compiler-level programming based on SIMD instructions. In this context, a single instruction is executed in parallel on multiple data elements as opposed to executing multiple instructions. Several levels of compiler optimizations can be achieved by loop optimizations, which in turn increases the performance of the applications and decreases the energy consumption. In OMR and OpenG9, SIMD support is more mature in the IBM Z and PowerPC platforms than on x86-64. As a Java virtual machine, OpenG9 Optimizer will perform vectorization. To perform this process, OMR needs to have the ability to utilize the full 16 bytes of register width for the vector operations and the functionality to execute AX64 specific vector instructions for various vector data types. Work is in progress in OMR for SIMD support on the AX64 platform. In summary, the future scope of the AX64 support for OMR is very promising, and we are excited about the prospects of this project. Thank you.